Welcome to this tutorial about repairing sound recordings in iZotope RX. The first thing I'd like to mention is that I am not a sound engineer and this tutorial is not for sound engineers. This is a tutorial for filmers who need to recover footage that has too much noise in it. I know that film editing software like DaVinci or Premiere include tools to reduce noise, but they are not very flexible and offer little control. In this tutorial, I will use a surgical approach that only iZotope offers. So this is the main interface of iZotope RX, and I have loaded an audio file into it. You can see the familiar waveform of the audio recording. On the right here, we have the various modules the software offers. I'm going to surgically edit the audio recordings, so I will just use three modules: Deconstruct, Dialogue Isolate, and Spectral Repair. Let's have a look at Deconstruct. The interesting thing is that it makes a distinction between tonal, noisy, and transient. Tonal is a narrow frequency band. Noisy is no particular frequency. Transient is a sharp burst of noise. I can attenuate each type separately, which makes this tool very selective. Spectral Repair I am going to use to attenuate selections. I am using a low strength. It is better to use several passes at a low strength than it is to use one pass at a high strength. I am going to execute these modules many times for each audio file, so I have associated key shortcuts to save time. Deconstruct is on key 7 and Spectral Repair is mapped to key 5. Let's listen to our sound recording.
I like modeling. I like modeling.
So the voice is fine, but the beep underneath is just way too much, so this has to be fixed. It's difficult to see what can be done here in the current display, so let's change it. Now what we are looking at is the spectrogram of the same sound recording. It just shows the same sound in a different way. You will notice the zebra stripe type things here, and that is what voice looks like. So these are letters and words. And this line, which looks very unnatural, that is our tonal noise. We have to remove that without damaging the voice. So let's do that. The first thing we need to do is select it carefully and then attenuate it. I have no choice but to attenuate even when the noise overlaps voice, because the voice won't mask the noise sufficiently. I am also selecting all its harmonics since there are several bands of tonal noise here.
I like modeling. I like modeling. I like modeling.
So the beep is gone, but it seems the tonal beep came with some non-tonal noise too. Sounds like a sewing machine. It seems these lines here we also need to eliminate. Here, and here. It is important to understand where the voice ends and the noise starts. Gaps between voice sounds can be cleared without much discretion. Other parts have to be attenuated carefully so as to leave the voice intact. Let's see what that gives us.
I like modeling. I like modeling. I like.
There is still a little bit of noise audible. Let's look a bit more closely.
I like modeling. I like modeling. I like modeling. I like modeling.
It's much better. Let's see if we can remove the last little bit of noise.
I like modeling. I like modeling. I like modeling. When I do, I like modeling.
It's much better. I've removed about 85 to 90% of the noise. If you polish it a little more, you can probably remove nearly 100% of the noise. In most cases, that is not necessary. It may already be good enough to remove 90%. Let's move on to our next example. This is a really tough one. It's a police siren. Let's listen to it.
My name is John Hyman and I'm a yoga teacher from LA. I would like to take a yoga group to Nepal.
The police siren is just an absolute killer here. No way that can be used in your production, so we have to see if we can clean it up. It's not an easy one since it is very loud and crosses all our words. It's tonal again, but it rises and then falls, so it's tricky tonal. So it starts here and I have to select it freehand like this. Once I have selected all the tonals, I will run deconstruct and spectral repair on them. I will speed up the editing process as it may take some time. This is voice, but I suspect there will be noise over it.
My name is John Hyman. My name is John Hyman. My name is John Hyman.
That's the CH sound from the word teach. And that's the J sound from Joan. Everything in the middle can basically go. I think the siren needs to be more attenuated. Maybe dialogue isolate can help us isolate the noise further.
My name is John Hyman and I'm a yoga teacher from LA. My name is John Hyman. My name is John Hyman and my name is John.
I can still hear some siren in this area.
My name is John Hyman. My name is John.
This part here may also be noise.
My name is John Hyman. My name is John Hyman.
I think I will have to attenuate this part, but carefully, as it is part of the voice.
My name is John Hyman and my name is John Hyman and I'm a yoga. My name is John Hyman.
I damaged a word here. Okay, undo. But I will still have to attenuate this bit here.
My name is John Hyman and I'm a yoga teacher from LA. My name is John Hyman and I'm a yoga teacher from LA.
I have made a lot of changes now. I tried to leave the voice intact and managed to remove around 80% of the noise. It would take much longer to remove the next 10%, but this recording may already be good enough for use in a production. Our next example is passing car noise. Car noise in film footage is a very common irritation, but I am not going to spend much time on it because it is easy to fix, at least in iZotope. Let's listen to it.
Passive behavior in like yoga is this opportunity to connect deeply with.
We can clearly hear the car noise. It's quite loud. The noise is up here, but there is also low frequency noise. The tricky bit is that some of the voice sounds, for example letters T, C, and S, are obscured by the car noise, so we don't know what we can select to attenuate. In this case, we can combine a blanket approach with surgical editing. Let's run dialogue isolate on the whole recording. It did not clean up all the noise, but that's fine. So this has nicely shown us the difference between voice and noise. All we need to do now is clean up around the voice sound up here, and down here, and between all these letters and words. As we have seen in previous examples, with a little bit of polishing, we can remove nearly 100% of this type of noise. Our next example is a car horn.
Our society, I think, rewards excessive behavior, and like yoga is this opportunity. Our society, I think, rewards excessive behavior.
There is a loud car horn in the background. This must be repaired if we want to use the recording. It's tonal noise again, but
Our society think our society think our society.
Our. So that's this part here. Society. This is the S. Below is the O. So this is the S. That's the C. Everything in between can basically disappear. We can go in here quite aggressively and attenuate the whole area. I have to make sure I'm leaving the voice intact, so I'm trying to follow its contours. I can probably select to about up here. I think there should be a distinctive gap between the S and the C sound, so let's clean this up. Okay, I am happy with this gap. This looks too bright to me. Let's bring down the volume.
Our society think our society think our society think our society think reward our society think reward our society think rewards our society think rewards our society think reward.
I can still hear a little bit around this area.
Society, 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 society.
But it isn't obvious where the horn is hiding. I will attenuate the upper frequencies a little. Got it. I think some of the tonals that we thought were gone extended into the voice.
Our society think reward our society think our society think our society think reward our society think
I can't hear any horn beeps anymore. I am satisfied with the result. It took a little bit of time and effort, but I think we lost around 90% of the car horn noise. Let's look at our last example edit. Our next example is cutlery and plates on tables, for example, in a restaurant. Perhaps you are taking an interview in a restaurant, but the noise has ruined your shot. Let's listen to it.
We're also able to really choose. We're also able to really. We're also able to really.
So we have some tonals, transients, and noisy parts. A brief look at the spectrogram tells me that the noisy parts obscure the voice. That's not good. Let's try and separate them with dialogue isolate, so let's run it. So, this has given us a much better idea where the noise is in the spectrogram. Dialogue isolate has isolated the voice for us. So we are free to clean the noisy parts and tonals without touching the voice. So this is the also, and that's the letter S. The part in the middle looks like the letter L. Let's attenuate what we know is noise. This is the word also to about here.
We're also able to. We're also able to. We're also able.
There is some more high frequency noise between also and able. Everything above can go. This part looks similar to noise, but it isn't.
Able to really. We're also able to really choose.
Okay, that seems good. Let's clean the next word, too. Let's see. This is the letter T and below the O, which is pronounced really long. And then right of the letter T and above the O, we have the tonals and the noisy haze. It's just hard to tell where the O starts. It may be a matter of trial and error here. Let's see if I did any damage.
To really.
And I did not. That's good. Maybe I can bite off some more here.
We're also able to really choose. We're also able to
It seems I can. This part could be attenuated more, but it doesn't seem necessary. I cannot hear any more noise. This concludes our tutorial. I hope you found it useful. Thanks for your attention.